Edit nyo na lang.
So our interest is the ASH rate and OSHA. So for ASH rate, we have for the particulate matters 150 micrograms per meter cube in 24-hour exposure, and the OSHA is a 5,000 ppm on an 8-hour exposure and 30,000 ppm in a 1-hour exposure. So the next one is the Environmental Protection Agency Ambient Air Quality Standard. So this standard aims to control emissions from the outside, such as industrial emissions, and the emissions of large-scale machinery, such as cars, and can be used. This standards standards can be used indoor only when the outdoor air is a heavy influence to the indoor air. So there are primary and secondary standards. So the primary standards provide public health protection, meaning that they care about the children, the asthmatics, such as, and the elderly, their health. And secondary standards provide public welfare protection, such as low visibility and damage to animals, crop vegetation, and buildings. So in our our pollutant of interest, particulate matter, we already have the standard for primary, secondary, and secondary. For PM 2.5, we have 12 microgram per meter cube in an annual mean, average over 3 years. So the exposure time is about a year, and the secondary is about a year, 15 micrograms per meter cube, and annual mean, average for over 3 years. So for the primary and secondary, the maximum of 24 hours has been as the average in time, and the maximum is 35 micrograms per meter cube, average over 3 years, 98%. And PM10, primary and secondary, 24 hours and 150 micrograms per meter cube, not to be exceeded more than once per year, an average in over 3 years. So, Occupational Safety and Health Administration workplace standards. So, workplace environment is subjected under OSHA, such as exposure in offices, and it's limited since indoor air quality is another concern. So, what I've seen in their website is that they don't actually have indoor air quality standards, but they only have like guidelines in order for you to follow to be exposed in such contaminants. It's worth taking note that their exposure limits are updated since its publication back in 1968. So these are the contaminants as follows. Next. And the next one is American Conference of Government Industrial Hygiene and Workplace Guidelines. So this guideline is actually annually updated. They have been evaluating workplaces, and then they practically update each. Used in workplace exposures and comes in 15 minutes to 8 hours of exposure limit. So it limits workplace exposure to 8 hours. That's to healthy adults ranging from the age 18 to 65 years, and does not cater to residential exposure since it's used in workplace. So in here we have carbon dioxide as is practically the same as OSHA, and our particulate matters. So indoor air quality, pollutant, and HVAC system interaction. So as you well know that air conditioning units have lots of parts. So it might be a breeding ground for chemical contaminants and biological contaminants, as well as HVAC systems similar to our canteen can proliferate air contaminants. So for the baseline of indoor air quality, so in order to comply to the ASHRAE standard 62.1, first, a contractor of the agency must first evaluate the performance of the HVAC in the rooms or area of interest, and then the study examines the ventilation rate and inspects with occupants. So classroom versus indoor air quality. Three factors to approximate the performance. First, air temperature. Second, carbon dioxide concentration. And third is relative humidity. The maximum performance is attained at 27 degrees Celsius during cooling season. And there is a minuscule decrease in performance, only 0.6%, even if the carbon dioxide skyrockets about almost double at 87.5%. And air temperature causes immediate effect to performance students. For example, you've been in a really hot room and really affects your performance because the irritability of the environment to you. And while insufficient ventilation rate, it needs to longer exposure to experience adverse effects because, as I've said, if the ventilation rate is really bad, there's a there's an increase of carbon dioxide concentration. But it has been found out that, again, a minuscule amount can only be affected in your performance based on heightening concentrations of carbon dioxide. So that is all for my presentation. May I call on my groupmate for theoretical considerations. Thank you for listening.
Good morning, members of our panel. I would be discussing the Chapter 3 theoretical considerations for our IEQ baseline study. So let's start off with the first theoretical consideration, which is ventilation. So ventilation is the supplying of fresh air inside the room or on the building. So ventilation can either be natural or forced. And it is also important in reducing the amount of carbon dioxide concentration in a space. And the next one would be carbon dioxide concentration. So if there's too much concentration for carbon dioxide, it can